Once we start including charging electric vehicles at home, the picture of the energy consumption in our cities will change. This graph shows the energy use intensity for the 50 projects in average for the building standards that we have considered without any EV charging. Once we do include the EV charging, we substantially increase the energy consumption at home because we no longer refuel our cars at the gas station, we charge them at home. And you can see the dashed gray line boxes on top of the solid gray as the increase of the energy consumption in average for homes once we start charging 2 electric vehicles at home. This is what this graph shows. So the gray solid is still the same energy use intensity for heating, cooling, domestic hot water, and appliances, as well as PV compensation in the case of the California Title 24. And then the box with the black and white lines across is the energy consumption in average per year to charge 2 electric vehicles at home. This is based on standard mileage for American cars, as well as the average efficiency current for electric vehicles, so kilowatt hours per mile. Now, the good news is that today we have a choice. We can either continue building buildings that are this energy inefficient, and that is what the orange circle identifies in the graph on the right hand side. That highlights the energy consumed by a regular code-built building with zero EV charging. And if you follow the dashed line to the right hand side of the graph, you will see that for the same amount of energy, you can have a passive house and charge 2 electric vehicles without an actual increase in the overall consumption. So we have a choice, and passive house in this case provides a very viable option to start basically to enable the transition to electric vehicle charging at home without increasing the infrastructure that we would otherwise need if we keep building buildings that are as inefficient as they are today. So looking at the EV adoption, in average, passive building standards allow to charge electric vehicles at home without significant increase in the infrastructure. Infrastructure, I mean the grid, the electrical grid. We will, once we start adding more and more electric vehicles, we need to produce a lot more electricity, and switching to passive house for construction as the energy standard dramatically reduces the need for energy in buildings, and that frees up the bandwidth in our electrical grid to then switch vehicles to be electric instead of dependent on gasoline. Looking at the size of PV systems to get to net zero, we saw earlier how the current definition of net zero set forth by ASHRAE Standard 228 includes the energy used to charge vehicles at home. So in this graph, we see the smaller light gray circles represent the size of the PV system only to offset, to get to net zero, only to offset heating, cooling, domestic hot water, and domestic appliances. And you see the larger dark gray circles include also charging 2 electric vehicles at home. And you see on the right hand side of the bubble graph how passive house standards allow to make it happen. Basically, there's only so much rooftop area or area on your site that you can dedicate to installing PV panels, and so offsetting a code minimum built home and true electric vehicles, it becomes a very large PV system that is on one side much more expensive, but also you may not have enough rooftop area or area on your site, on your lot, to do that. So the Passive House standards allow to actually maintain the goal of getting to net zero once we start considering the charging of electric vehicles on site.